The I can statement for 7.4 is I can evaluate operations with functions. So go ahead and write down functions right here. In the last section, we did operations with functions. Now we want to evaluate those operations with functions. So let's take a look at the warm-up. It says, what does the word evaluate usually mean? Well, when we say evaluate something, what we normally mean is find a number answer. Find a number answer. So on this one right here, this just says find f minus g of x and f divided by g of x with this f and this g. So let's go ahead and do the subtraction one. Again, the subtraction one we've got to be a little bit careful with. I'm just going to go ahead and write down 6x squared minus x minus 10, and then I'm going to write down minus. I'm going to put this stuff in parentheses, 5x minus 2. So this is going to be, let's see, if I distribute through, I'm going to have a minus 5x and I'm going to have a plus 2. We only have one x squared term, so we've got that one taken care of. We've got a minus 1x and a minus 5x, so that's going to be a negative 6x. Done there. And then we've got a negative 10 and a 2. We're going to combine those together, so we end up with a negative 8 right there. Okay, so that's what we get when we subtract. Again, those parentheses are important so that you distribute that multiplication through, that negative through there, if you will. Then we're going to do the division problem. On this division problem, so if we do f divided by g of x, here's what we get. We're going to put the 6x squared minus x minus 10 on the top, and we're going to put 5x minus 2 on the bottom. Now again, we might look at this and say, gosh, can I cancel the 2 with the 10? Can I cancel the 5 with the 10? Could I cancel the 2 with the 6 and so forth? Gosh, could I even cancel off this x with that x or this x with that x squared? Remember, we can only cancel factors, we can't cancel terms. And each one of these that we'd love to cancel, they're all terms. None of them are factors. We'd have to be able to factor this in order to simplify it. So that right there is the answer to that one. The ultimate goal here with performing operations with functions is that we want to be able to evaluate them so we have a number answer for them, so we have a function value, or maybe so that we can graph this new resulting function. Well, this is what we're going to do today. We're going to be evaluating operations with functions, and there are two main approaches to this. So here's the first approach. Evaluate each function for the given value, then perform the operation. And the opposite is number 2. So perform the operation with the functions, then evaluate the new function for the given value. So you can plug in the number that you want to find the function values for, then do the adding, subtracting, multiplying, dividing, whatever it happens to be, or perform the operation first and then plug in the given value. We'll take a look at both of these techniques right now. So let's take a look at number 1. It says find f plus g of x and f minus g of x for each f of x and g of x. So we want to find f plus g of negative 2, and on this one we want to find f minus g of 1. So let's do example 1a, first using the method number 1 where we evaluate the function for the given function value. So let's figure out what f of negative 2 is. F of negative 2, we'd have, I think we've done this one before, so this would be 2, negative 2 squared, minus a negative 2, and then minus that 8 right there. So we end up with, let's see, negative 2 squared is 4 times 2, this is 8. This becomes a positive 2, that's a minus 8, so those will cancel each other out, so we end up with a 2 here. Then let's figure out what g of 2 is, g of negative 2 that is. So we're going to multiply this by a negative 2. So 3 times negative 2 is negative 6, minus 2 would be negative 8. So we get negative 8 right there, and then we're literally just going to add these together. So we're going to do 2 plus negative 8, so we end up with negative 6 right here. So that's method number 1. Let's take a look at method number 2. On method number 2, what we would do here is let's perform the operation with the functions. So let's take these and add them together, and then we'll plug in the function or the value, the x value that we want. So let's see here. This is going to be f plus g of x. We're going to add those together. So we're going to have 2x squared minus x minus 8, and then we're going to add 3x minus 2. So that's going to give us a, let's see, 2x squared, get those taken care of. Then we're going to do the negative x plus 3x, that's going to be plus 2x, and put the negative 8 and the negative 2 together, we get a negative 10. Okay, so there's the new function. Now we want to evaluate that for f plus g of negative 2. So let's plug in a negative 2. So 2 and then negative 2 squared plus 2 times negative 2 and then minus 10. So we've evaluated this one before. Remember, we get an 8. So this is going to be 8 minus a 4 minus a 10. So this is 8 minus 14 when we put those two together. So we end up with negative 6. So you'll notice that they do end up the same. It doesn't matter which one you do. It's really just personal preference. So let's turn our attention to this one right here. This is f minus g of 1. So the first thing, and again, you'll notice that they did f of t rather than f of x and g of t rather than g of x. Sometimes we'll call that a dummy variable. You can change it out for anything that you want. But let's go ahead and figure out what f of 1 is. If we do f of 1, this is 4 times 3 to the first power minus 6. And then g of 1 would be 2 times 3 to the first power plus 7. So let's see what we get here. 3 to the first power is 3, so this is going to be 12. So 12 minus 6, we'd end up with 6 on that one. And then 2 times 3, that's going to be 6 plus 7, so this is going to be 13. And what we want to do is we want to subtract these. So 6 minus 13, we'd end up with negative 7. So we've evaluated this. Now we're going to do it the other way. We're going to do it with the operation with the functions first, and then we're going to plug in 1. So f minus g of, whoops, let's put an x right here because we want to figure out what that is first. And then we're going to take f, which is, let's see, actually I'm going to change back to that variable there. Got caught in my own trap there. So 4, 3 to the t minus 6, and then we're supposed to subtract whatever we have for g of t. So this is going to be 2, 3 to the t plus 7. So let's see what we've got here. This is going to be 4, 3 to the t minus 2, 3 to the t. And that's going to be a minus, let's see, what have we got there? Yep, that's a minus 7. So let's see, we have f minus g of t is equal to 4 of these minus 2 of these is 2, 3 to the t. Yep, got those taken care of, and then minus 13. So if we were to plug in a 1, so f minus g of 1, we'd have 2 times 3 to the first power minus 13. Let's see, 3 to the first power is 3 times 2, so we get 6 minus 13, so we end up with negative 7. So again, the same thing. Now, which approach do you like better? Do you like approach number 1 or do you like approach number 2? And do you have a reason for that? Well, I think you'd agree that by plugging this in here, we've got to do a whole bunch of algebra. We've got to change a whole bunch of things here. We've got to get this new function, and then we've got to plug in a number where if we just plug in the number here, plug in the number here, get each one of those function values, and then do whatever the operation is, addition or subtraction, then it's really not too bad. So I'm going to write down that we probably like method number 1. So probably number 1. So probably method number 1. Evaluate the function values and then do the operation. But let's slide down here and let's take a look at this other one. So on example 2, we've got a different operation. We've got multiplication and we've got division. So let's try that here. So let's go ahead and find, so this one is h times g of 3. So we want to find h of 3. And we want to find, whoops, I got those backwards. So that's a good thing to keep in mind. G of 3 here, and we want to find h of 3 here. Let's make sure that we put those in the correct order, especially when we get over on this one right here. So let's see, we've got g of 3. If we plug in a 3, that's going to be 2 times 3, that's 6 plus 2, so that's going to be an 8. And this one's pretty simple here, so let's plug this in here. So we have 4 times 3, that's 12 minus 1, that would be 11. So we've got the two of those, and then we just need to multiply those together. So whoops, 8 times 11, so we end up with 88. So we've got our answer right there. Now let's go ahead and do it the other way. The other way would be to multiply these together. So we're going to find g of, let's see, whoops, let me write it in the correct order. So we need to find h times g of t. So h times g of t. So we're going to take h, which is 4t minus 1, and we're going to multiply it by 2t plus 2. These are binomials, so we're going to go ahead and multiply here, here, and here. So we end up with, this is going to be 8t squared when we multiply 4t times 2t. When we multiply the 4t times 2, we end up with 8t. And then this is going to be negative 1 times 2, so that's going to be negative 2t. And then negative 1 times 2, that's going to be negative 2. So we have 8t squared plus, let's see, that would be 6t. 6t, and then minus 2. And what we want to evaluate this for is a 3. So h times g of 3. So let's plug a 3 in here. So this is 8 times 3 squared plus 6 times 3, and then minus 2. So let's see, this is going to be 9. 9 times 8 is 72, plus 18, and then minus 2. So if we put the two of these together, that's 72 plus 16, and 72 plus 16 is 88. Same thing either way, all right? So that one works out just fine. Now let's take a look at this one. So we need to find p divided by h of -1. Now notice that they played a little trick on us here. This is in a reverse order. That makes a big difference when we're dividing. So here's what I'm going to do. I'm going to put the p on the top so I don't forget that. So I'm going to find p of -1 here, and then I'm going to find h of -1 right there. Make sure we keep those straight. So remember, we're using this function right here. So this is going to be 4 times -1 minus 5. And then we're finding h of -1. So that's going to be the -3 times the -1 minus 3. So this is a -4 minus 5. So that's going to be -9. This is going to be 3 minus 3, which equals 0. Now here's why this is a really big deal, especially on this one. We want to find p over h. So if we do p of -1 and put it over h of -1, watch what happens here. We're going to have the p value is going to be -9. The h value is going to be 0, so we end up with undefined. Okay? Undefined. Can't divide by 0. So can't divide by 0. All right, so we run into a pretty major issue right here. So I'm going to go ahead and circle that, and let's see if it works out the same with the other technique. So on this one, we need to put p on the top. So if we do p divided by h of t, we're going to have p on the top, so that's 4t minus 5. And then we're going to have -3t minus 3 on the bottom. And what we want to do is we want to evaluate this for -1. So p over h of -1 is going to be 4 times -1 minus 5. And then -3 times -1 minus 3. Again, this works out to be that -4 minus 5. That's a -9 over here. And then we have a negative times a negative. That's a positive. 3 minus 3 would be 0. Same thing right here. Okay, can't do that. Okay, now, which one do you like better now? Do you like evaluating the function and then doing the operation, or do you like doing the operation on the function? Probably still number 1. So probably still number 1. It just works out easier, okay? It's easier and it's faster. Now, I do want to caution you a little bit, because down the road you are actually going to have to find out. They might just say, hey, I just want the rule of the function. I just want g of h of x or something like that. So literally all they would want would just be this right here. All they would want would just be this right here. So keep that in mind in the future. I do want to slide down here and take a look at this thought experiment. It says if f of 4 means plug in a 4 wherever there's an x in f of x, what do you think it means when we have an f, and then in a set of parentheses where the x normally goes, we have g of x? Stop and think about what that might mean. We're used to plugging things in, whether it's a t or a 3 or a -1 or plugging in a 4 like this right here. But look what we're plugging in on this one. What it means is we would actually plug a function into a function. Pretty mind-blowing there, but that's an example of where you might have to actually go through and do a bunch of arithmetic, a bunch of algebra and stuff like that in order to get the answer there. So go ahead and do the self-assessment and then get going on the assignment.